4, we need to find the radius and interval of convergence of this series. So what you notice here is that we have a 2x plus 3 to the n term. So depending on what x is going to be, this series may or may not converge or diverge. So what we need to do here is the ratio test to figure out what our interval is. So when we do the ratio test in this, remember we're not including the alternating piece. So we have 2x plus 3 to the n plus 1, so we use the n plus 1th term, n plus 1 ln of n plus 1, times the reciprocal of the nth term, because we're dividing by the nth term. We're taking the absolute value of all this stuff. So we multiply by the reciprocal of the nth term, which is just this. So we have n ln n over 2x plus 3 to the n. So we want this to converge, so we want this to be less than 1, since we're using the ratio test. And remember that we're doing here limit as n goes to infinity. So we have a few things, or we have one thing that can cancel out. If we have 2x plus 3 to the n plus 1 over 2x plus 3 to the n, this cancels out, and we're just left with 2x plus 3. But what we want to do here is we want to put the 2x plus 3 in absolute value bars, because we don't know if that's positive or negative. But clearly, because n is going from 2 to infinity, we don't need to worry about the absolute value for the n plus 1 and ln terms, because those aren't going to be negative anyway. So what do we have left? We have n over n plus 1. So I'm grouping the n terms together and the ln terms together, times ln n over ln n plus 1. And we want this all to be less than 1. Limit as n goes to infinity. Okay, so what you want to notice here is that these two pieces, the n over n plus 1 and the ln n over ln n plus 1, as n goes to infinity, these are all becoming the same thing. Or the n and the n plus 1 are becoming the same thing, ln n over ln n plus 1 is becoming the same thing. And you can, of course, test those by using L'Hopital's rule. But this is 1, and this is 1. So everything cancels out except what we have here. So we know that absolute value of 2x plus 3 has to be less than 1, which means 2x plus 3 is in between 1 and negative 1, and now we can solve for x. So if we subtract both sides of the inequality and the middle by 3, so we get negative 2 here and negative 4, and then if we divide by 2, we get that x has to be in between negative 1 and negative 2. So right away we can tell what our radius is. Our radius of convergence is going to be half, because our entire our entire interval of convergence there only has width 1. So our radius of convergence then is going to be 1/2. Excuse me. So what we need to find for the interval is, now we know that it's going to go from negative 2 to negative 1, but we don't know, are they going to be parentheses or brackets? How can you tell? So now what we need to look at is all of the pieces of this series that aren't the 2x plus 3. So let's see what happens when x is negative 2. If x is negative 2, up here we get negative 4 plus 3, which is negative 1. Two alternating terms just cancel out. So this is for x equals negative 2. The alternating things cancel out, and we just get the sum n equals 2 to infinity of 1 over n ln n. When x is equal to negative 1, the other end of this interval, this becomes 1 to the n, which just disappears. And we get almost the exact same thing. We just get the alternating version of that same series. So to determine whether these should be parentheses or brackets, we just need to test whether these series converge. So So let's just think about what's going on with 1 over n ln n. So that one can be easily tested by the integral test. And the reason being is that you can see here that the function ln n has its derivative, 1 over n, in the function. So remember that if anything has its derivative in the function, then that's a u substitution integral. That's pretty simple to do. So if we were doing the integral test, we would say the integral from 2 to infinity of 1 over x ln x dx. So remember that if this improper integral gives you a definite number as a result, then that series converges, and if it gives you infinity or some other does not exist type of thing, then you know that that integral or that series diverges. So we can do this by just saying u equals ln x, because then du is equal to 1 over x dx, and 1 over x dx is here in the function, so this works out perfectly. We get the integral from 2 to infinity now of just 1 over u du. So the antiderivative of 1 over u is of course ln u, and instead of u we have ln of x. So we get ln of x, and we're going from 2 to infinity. Typically you need to put 2 to x, limit as x goes to infinity, or t, or something like that. But you can see here regardless, when you plug in this part that's going towards infinity, as x goes to infinity, ln of that is infinity, and then ln of infinity is infinity. So we get infinity minus ln of 2. Which is not a definite result, because this is just infinity. So therefore that series diverges, 1 over n ln n diverges, which tells us that negative 2 then is not in our interval of convergence. So we have a parentheses on negative 2. So we need to do something similar for negative 1. Well, negative 1 gives us the same thing, except it's alternating. So remember that the alternating series test is actually significantly easier, because for alternating series, in order for it to converge, only 2 things need to be true. The part of it that's not alternating needs to have a limit that goes to 0, and it has to be decreasing. Well, as n goes to infinity, so the limit as n goes to infinity of 1 over n ln n goes to infinity, ln n goes to infinity, so this is 1 over something going to infinity, which is going to be 0. So that works by alternating series test. Next, we need to see, is that decreasing as n increases? Well, as n increases, and as n increases, ln of n increases, meaning this denominator increases, which means it is decreasing. So both of those things are true, so that tells us that this series converges by alternating series test. Obviously, it's not absolutely convergent because this didn't converge, which is the absolute value of it. So it's only conditionally convergent, but it is convergent by alternating series test. So therefore, negative 1 is included in our interval of convergence. So our radius was 1/2, and our interval of convergence was from negative 2 to negative 1, not including negative 2, but including negative 1.